Hello and welcome to the second session in the chromatography series. In the previous session, we talked about some of the basic terms used in chromatography, and we also discussed how different chromatographic techniques could be classified based on the scale at which they are employed and also depending upon the different types of phases that are used in different techniques. Today, we're going to talk about the first of these techniques, that is the thin layer chromatography. In short, we also call it the TLC. Thin layer chromatography is a type of adsorption chromatography. Chromatography could also be adsorption or partition. Adsorption chromatography means that the stationary phase that is used in TLC is a solid and the mobile phase is a liquid. There's competition between the flow of the components of the mixture in the liquid mobile phase or their retention by the solid stationary phase due to adsorption of those components on the stationary phase. And that is why the name adsorption chromatography. TLC could be used at both analytical and preparative scale. So you could just analyze your mixture, or you can also purify the components of your mixture when TLC is used on a preparative scale. But there's a slight difference in the thickness of this thin layer. The thickness of the layer for analytical purpose is usually between zero point 0.1 to zero point 0.2 millimeters, but it's slightly thicker for preparative purposes, that is from 0.5 to 2 millimeters. So let's see the different steps involved in the experiment. In an experiment of thin layer chromatography, the very first step is to prepare the solution of your sample in any appropriate solvent. So the first step is to prepare the solution of the mixture in any appropriate solvent in which all the components of that particular mixture would be soluble. And then, of course, you will have to prepare a chromatogram that has a thin layer of adsorbent supported by any other layer. For example, you have to prepare a thin layer of silica on an aluminum sheet. Those are the pre-coated aluminum plates that are usually available in the market for TLC experiments. So you have to prepare a chromatogram, and this you can see here has a thin layer of silica on the aluminum plate, and you have to apply your sample on the chromatogram with the help of a capillary tube. So you just dip your capillary tube into the solution that you have already prepared and then just touch it down here on this thin layer, and you will see that the sample along with the solvent would be applied on this line which we called the baseline. So you just apply your mixture on this baseline and wait for a while so that all the solvent evaporates, and that will leave your sample adsorbed on this solid stationary phase. So you can apply as many samples as you like. The third step is to prepare the mobile phase. So depending upon the nature of your mixture or the components of your mixture, you have to prepare a suitable mobile phase that is suitable for effective separation of the components of the mixture, and also it must leave all the components between these two lines, that is the baseline and the solvent front. This is the line up to which your solvent will flow during the experiment. So all of your components must be visible on this chromatogram between these two extremes, that is the baseline and the solvent front. So you just prepare your mobile phase, that may be a pure solvent or it may be a mixture of two or three or more solvents of different polarities in different compositions, in different ratios, and you just put it in a chromatographic tank. The next step is to insert your TLC strip into the mobile phase. Now, there are certain things that you have to keep in mind while doing this. So, when you just insert your TLC plate or your TLC strip in the mobile phase, make sure that your baseline or the spots of your sample or the mixture are not dipped into the liquid mobile phase, because that will dissolve all the components of your mixture and you will not have a good result. So the baseline has to be slightly above the surface of this mobile phase, and you will see after a while that this liquid mobile phase starts rising up this TLC strip due to capillary action, and as soon as it reaches here the baseline, it will try to dissolve the components of this mixture, and as it moves on it will try to carry these components. Depending upon the differential solubilities, they will move up with the mobile phase. At the same time, they will be interacting with the solid stationary phase by adsorbing on it, and the different RF values of these components will then depend upon the solubility in the mobile phase and the adsorption on the stationary phase. So after a while, you would see that all those components which were applied here on this baseline have moved up with the solvent, with the mobile phase which has moved up to this level. This is the solvent front, and you can see that all of these components have gone up with the solvent system or the mobile phase up to different levels, and that depends again upon the solubilities in the mobile phase and the adsorption on the stationary phase. And the final step is to calculate the RF values of each spot or each component of your sample. So that is the ratio of the distance covered by the component to the distance covered by the mobile phase or the solvent front. So you can see the values here. RF value for this component is 0.38, the RF value for this component is 0.72, and the RF value for this component is 0.30. So as discussed previously in the first session, that chromatography could be normal phase or reverse phase. If it is a normal phase TLC profile, then it means that the one that has the lowest RF value will be the most polar of these three, and the one with the highest RF value would be the least polar of these three. But if it is a reverse phase TLC profile, then this one with the highest RF value would be the least, will be the most polar of all of these, and this one here with RF value 0.3 would be the least polar of all. Now let's see how you can calculate the RF values. As I told you earlier, that it is the distance traveled by the sample or the component in centimeters divided by the distance traveled by the mobile phase or the solvent front. So you can actually measure the distances with the help of a ruler and you will get the RF values. And as you can see that it's a ratio between similar units, and that is why it is unitless. And as I told you earlier, that you have to select a suitable solvent system or mobile phase that brings all of these components between the two extremes, that is the solvent front and the baseline. So it means that all the components of this mixture will lie between the two lines, and that is why it means that none of them has traveled the distance the solvent has traveled, and that is why it is always less than 1, because this distance traveled by the component is always less than the distance traveled by the mobile phase. So the RF values for all the components have to be less than 1. So this is all about TLC, some of the basic things about thin layer chromatography. We might discuss the technique in more details later on. So stay tuned. Thank you so much for watching.